Hello everyone, welcome to CS30. CS30 is one of two subjects you will take to learn about discrete mathematics. As given here, CS30 is Discrete Mathematics for Computer Science 1. The other subject is CS31, which is Discrete Mathematics for Computer Science 2, and is the next subject you will take after CS30. You may ask, this is computer science. Why do we need discrete math here? First, you have to realize that most of computer science deals with mathematics. So we need to embrace math as early as now. What is discrete math? Let's talk about what is discrete first. According to Oxford Dictionary of English, which is just the dictionary I have on my computer, discrete means individually separate and distinct. According to Wikipedia, discrete is the opposite of continuous and is something that is separate, distinct, and individual. So the keywords are separate and distinct. Discrete math is thus the branch of mathematics that study discrete objects. Some examples are as given below. Integers, 0, 1, -1, 2, -2, and so on. Instructions taken by a computer program. Distinct paths to travel from a point A to a point B on a map. Ways to pick a winning set of numbers in a lottery. And a lot more. There's a lot more that qualify as separate and distinct. More importantly, computers can only handle discrete structures. Fortunately, most of the problems in real life can be modeled as problems on discrete entities. So some are already listed here. Although these are very specific questions, they are actually representative of the different fields in computer science. So for example, this one can be a question on security. This can be a question on computer network. This one talks about probability, which actually has a lot of applications. I think this is important in big data. This one, circuit, you can think of this as representative of computer architecture. You can think of this as a question in programming language or machine learning. And this is just a very short list, as can be seen in this CS subject dependency, which will describe your whole BSCS journey, and you are here. So, what can we observe? Observe that CS30 and CS31 is a prerequisite to many subjects you will take later. So let's just take a look at these subjects. This is CS30 and CS31, which is discrete math. CS32 and CS33 are subjects on algorithms and data structures. This one is machine learning, software engineering, programming language, operating systems, computer networks, security. This is still software engineering. This is database. This is automata and computability theory. So, what does this mean? This means that the concepts that you will encounter in discrete math will be revisited and needed in these succeeding subjects. In fact, they are there and will be there throughout your CS life. Discrete math is also a gateway course. It not only has applications in computer science and mathematics, but even in other disciplines. With most of problems being interdisciplinary today, a good background in discrete math is definitely a plus. For me, discrete math provides a foundation for solving problems. All these fields have complex problems, and usually, when solving complex problems, we first try to abstract the problem by constructing simplistic models. The purpose is so that we can mask the irrelevant details first and concentrate only on the most important ones. Now, thanks to discrete math, we will then find that most of these problems have already been well studied by uh, cool mathematicians and computer scientists. And you will learn that you only need to adopt or modify existing solutions and maybe eventually contribute to this body of knowledge as well. But in order to understand the solutions, you first have to understand the quote unquote language by which the problems and solutions are written. And a course on discrete math gives you a starter. So, what are the topics that we will cover in CS30 and CS31? So, listed here are the main topics, both in CS30 and in CS31. Uh, let's start with logic. Logic is mainly the study of valid reasoning. The focus of propositional logic is to study propositions. Propositions or statements are declarations that has exactly one truth value. It can be true, it can be false, but it cannot be both. In predicate logic, we will enrich the tools that we will learn in propositional logic to make it more powerful. So with logic, we will learn how to formally state truths and how to derive truths from other known truths. We will be able to construct and validate mathematical arguments, which we will use in the next topic, which is methods of proof. Here, we will learn different strategies in proving. We will be using the techniques we learn in methods of proof to prove the properties concerning the succeeding topics. Here, what is a set? A set is a collection of discrete elements. Relation is a set of ordered pairs, and a function is a relation. Um, an algebraic structure is a collection of operations on elements of a set. So you may observe that these are fairly simple structures. You can pick up some things and you already have a set. You get two sets, you combine them, you get a relation. You define some operation on this set and you can define an algebraic structure. As simple as they may sound, the concepts that we will learn are fundamental. The properties that we will learn, and some of them we will prove, is present and is applicable even in more complex structures that are discrete in nature. So I hope this gives you a good overview of what to expect in this course. If you have any more questions, you can just email us in these addresses. I hope you will learn a lot and also enjoy learning. So that's it. Thank you for listening.